Okay, we want to establish another result before we get to the main result, which is the Steiner-Lehmus theorem. Steiner-Lehmus theorem is saying that if the internal angle bisectors, two of them are congruent, then the triangle's isosceles. Now, here is our lemma 2. We're given two acute angles. If you're given two acute angles inscribed in a circle, the chords that they correspond to, the subtending chords, here's an acute inscribed acute angle. The subtending chord is CE, okay? The relation between subtending chords, okay? Let's look at another subtending chord. Here's another acute angle here. Let's see if we can draw one. Now, in this diagram, we draw the acute angle, and then we put it. We have all the symmetry that we put in the diagram. We take diameter AB, and here's your angle that we're considering here. Considering angle theta, and we put it at the bottom of the circle, and then we have a central angle here at COE is a central angle that corresponds to the angle theta. And we know that this is also theta because the central angle is twice the inscribed angle that corresponds to it. This is a unit circle. The radius is 1. So now, what would this be? Well, this is going to be sine of theta. It's opposite. This is going to be the sine of theta is opposite, the side opposite. So there's another sine of theta. So what we have is 2 sine theta is so the length of CE there is 2 sine theta. And then we have another, we take a wider angle. Here's your wider angle, and you can eyeball that it's corresponds to the larger subtending chord, the longer subtending chord. But we don't need to just say that. What we can understand is that as C approaches A, and corresponding E approaches B, then we know that the inscribed angle approaches 90 degrees, because we know that an angle inscribed in a semicircle is a right angle. Okay, and we also know about the sine function. Sine is increasing on the interval between 0 and 90 degrees, or pi over 2. So as this angle gets larger, the the corresponding chord, the subtending chord there is also increasing, because sine theta is increasing, because sine is increasing on the sine function increases from 0 to sine is increasing from 0 to 90 degrees. Sine function increases. So 2 sine increases also. Sine function increases, 2 sine increases. Until, so it's going to be true that FG is going to be longer than CE, because it has a larger angle. And this is this result, which I kind of slopped up a little bit, but the result is it must be discussed, because it's not true when the angles get really large, when they get to be obtuse. Okay, the inequality is reversed. So on this other one, we have that we have that CE is less than FG, but if you go down here, the wider angle has the shorter chord. So the inequality is going to be reversed. We could do more to prove this, but what we could use coordinates, and it's very easy to prove using coordinates. However, I think I did a lot with the sine function here to show you that this result is right. The smaller angle corresponds to the shorter chord when the angle is acute. So now we move on to the proof with these two lemmas in tow.